This video is going to look at the first batch of the multiple choice questions from the Redox questions. So just questions 1 to 8, and then the remaining questions will be in a separate video. So the first 6 questions are just a little bit of practice on calculating oxidation numbers in compounds. So question 1, we have sulfur and sulfur trioxide. My oxygen is -2 and there are 3 of them, which gives me -6. It's a neutral compound, and so therefore my sulfur must be C plus 6. Chlorine and NaCl, nice and easy, it's reacting with a metal, must be negative, it can only be -1, so that would be A. Chlorine in ClO4 minus, so this time we've got 4 lots of -2 for my oxygen, adds up to -8. The total for the iron is -1 as a charge, which makes my chlorine +7, which is D. Oxygen in hydrogen peroxide, so -2 is not an option here anyway. Remember, this is the unusual case where because the hydrogen is +1, the oxygen is -1, and that's because of that bonding where the oxygen is bonded to a hydrogen atom but then also bonded to another oxygen atom. Manganese in potassium manganate, so we have total of -8 again for the oxygen. We have a +1 from the potassium because it's group 1, which makes my manganese +7, which is D. And then number 6, phosphorus is going to be +3, which is B, and that's because each chlorine, the chlorine is more electronegative than the phosphorus, so the chlorine will be -1 and the phosphorus will be +3. Hopefully those ones were relatively straightforward. Number 7, we've got some balancing to do. So one thing that's really helpful in this equation is that they've given you I2 without an X, Y or Z or anything else in front of it. And so we immediately know actually that there must be 2 iodate ions because there is no other substance containing iodine on the left hand side. So that's a really useful helping hand. So I've already cancelled out A and D, and I must be choosing between B and C. So I'm going to use oxidation numbers to work this out. So it's iodate 5. So what I've got on the left hand side is 2 lots of +5, and on the right hand side I've got 2 lots of 0. So my change in my iodine is that I'm gaining 10 electrons in total. Now going to look at the change in oxidation state of the sulfur. So in the HSO3 minus, the whole thing adds up to -1. My oxygens add up to -6, and there is 1 hydrogen which has an oxidation state of +1. So +1 and -6 gives me -5. What do I need to add to -5 to get -1? +4. So on the left hand side the sulfur is in +4 state, and on the right hand side, if I do a little bit of working out, then I've got -8, the total is -2 for the charge on the iron, so that gives me a -6 to account for, so therefore my sulfur must be +6. So my changes, I just rub out all of that confusing stuff there, is the sulfur goes from +4 to +6, which means that it's losing 2 electrons each time it does that, which means I'm going to need 5 of them to counteract the 10 electrons that are gained, and so we're looking for 2, 5, 5, which is C. Now actually we could have done a shortcut there. We could have done a shortcut because there's only one sulfur containing substance on the left and on the right. So Basically, once I'd worked out that I needed 2 iodines and I therefore needed 2 iodate ions on the left, then I could have just deduced that Y and Z need to be the same number because there's 1 sulfur in each of those ions and there's only those ions that contain sulfur. However, I've done it with oxidation numbers just so that you know how to do that in case it wasn't a multiple choice question, in case you needed to balance that equation yourself. That's showing you how you would do it with change in oxidation number. And then number 8, which of the following is a redox reaction? So there are some things I can definitely discount straight away. So looking at D is a classic acid-base reaction. The only thing that's happening is hydrogen is being transferred. Everything there is hydrogen with a +1, oxygen with a -2. So the only time I'd expect hydrogen or oxygen to take part in redox is if I were to see elemental hydrogen like H2 or elemental oxygen like O2 with a compound on the other side of the equation, because then obviously there must have been some loss or gain, or if I see hydrogen peroxide, H2O2. Most of the reactions with hydrogen peroxide also involve elemental oxygen. Okay, what else can I discount? Well, I can discount A as well, because again, I've got normal compounds of hydrogen and oxygen there. If I work it out for the carbon, that's the only thing that could potentially change. Well, for a start, that's a clue, because if carbon's the only thing that's probably going to change and everything else, hydrogen is +1, oxygen is -2, that's already telling me there's no redox unless there were disproportionation. There can't be disproportionation because carbon only appears once each side, but we can prove it with oxidation numbers. So the oxygen in hydrogen carbonate adds up to -6, hydrogen adds up to +2, carbon is +4. On the other side, carbon is also +4. So it's not A. And B is a precipitation reaction. There's absolutely nothing going on there. That is simply 2 ions coming together, forming ionic bonds, but there's no transfer of electrons. So we're looking at C. Hopefully it's obvious because it's a displacement reaction and all displacement reactions are redox reactions. And the reasons that they are is that in order for zinc to become zinc sulfate, to go into the compound, and for copper to be displaced as an element, there must be a change in oxidation number because all elements are 0 and the metal ions will have positive charges. So it's easier to see in the form of an ionic equation for that one. And you will do more about that sort of reaction involving metals next year.